So welcome everyone to the IDEAS seminar. This is the seminar for the Center for Informed Democracy and Social Cybersecurity, CMU Center for Disinformation, Hate Speech, and Extremism Online. Today, I'm delighted to introduce our speaker, Ashique KhudaBukhsh. I probably murdered his name. He'll be talking to us today about novel frameworks for quantifying political polarization and mitigating hate speech. Let me first tell you a little bit about him. He is currently a project scientist here at Carnegie Mellon in the Language Technologies Institute. His background and research involves both natural language processing and artificial intelligence for social impact. He has applied this to a number of globally important events arising in linguistically diverse regions. He uses text that is both multilingual, noisy, often from social media. His work on polarization has been done in the context of the current US political crisis, and his research has been accepted at top AI journals and conferences, and has received widespread international media attention, including coverage in Wired, Salon, The Independent, and Digital Trends. In addition to this, I want to point out that he is also terrific at playing chess. So if you want to play chess, this is the go-to person. He has an over 2,100 rating that he was able to achieve during COVID. With that, I would like to turn it over to Ashique. And again, welcome and thank you for giving the talk today.
Can everyone see my slide?
You're in presentation mode. Yes, you're good.
Yeah. Hello, everyone. First, thanks to Kathleen for this wonderful introduction and for this wonderful opportunity to present here. So I'll be presenting a talk on novel frameworks for quantifying political polarization and mitigating hate speech. And I understand that there is a very broad and diverse audience from social science, natural language processing, machine learning. So I have tried to make the talk as accessible as I can. There will still be few machine learning or natural language processing terminologies, but my hope is you will be able to get the broad vision and ideas of this presentation. So in this talk, I'll be presenting two broad research directions. The first one on a novel framework to quantify political polarization. And in the second part, I'll talk about a framework to mitigate hate speech. So in the first part, I focus on the US political landscape with a specific emphasis on the build-up to the 2020 election. Much before that, this is a Pew Research survey between 1994 to 2014, where registered Democrats and Republicans were asked policy-related questions. And as you can see that as time progressed, among the Democrats, the consistently conservative responses have thinned, and the median between the Republican response and the Democrat responses have drifted apart. And more Democrats have become consistently liberal in their policy choices, and more Republicans have become consistently conservative. Now, this deepening political divide and the role of hyper-partisan news media is well established. Their partisan and ideological divergence in both content and audience has been well reported. In this work, we focus on four major US cable news networks: Fox, CNN, MSNBC, and One America News. But we mainly focus on their online presence. All these news networks have massive YouTube presence in their official YouTube handles. So these numbers are from 2020 August, but you can see that already by then, all these big three news networks have YouTube subscribers in the order of millions. We also considered One America News Network a fringe conservative network in our analysis because it was the former president used to tweet about One America News highly favorably. So here is how the information is flowing. This is everything that's going on in the universe. And then a subset of that are events interesting to United States. Then subsets of these events are covered by these news networks. And we hope that these subsets have a strong overlap. and then their coverage is reaching a broad and diverse audience. Again, the audience sets are not identical. There will be some overlap, but there might be audience who just consume specific news networks. Now, when they watch these YouTube news videos, they respond to it in the forms of likes, dislikes, and they also comment on these news videos. This gives rise to a very rich and novel data set of user comments on news videos. In this graph, you can see that it starts right when the Pew Research survey stopped, 2014 to 2020. And you can see that over these years, the average numbers of comments per video for each of these news networks' YouTube handles have increased. And we have constructed a data set of more than 85 million comments posted on more than 200K news videos over these 6 years from these 4 news networks. Now, how do we shed light on polarization in these large-scale discussion datasets? We kind of know that MSNBC discussion or Fox News discussions will be different, but how do we quantify differences between these large-scale social media discussion datasets? Polarization has been widely studied in social science. A seminal line of work was performed on using congressional votes to measure polarization in political science. In computational linguistics, there has been a recent work that focused on mass shootings and polarization. The network analysis studying manifestation of polarization also has a rich literature. In this work, our challenge is very different. We are trying to address how to quantify polarization on large-scale discussion datasets discussing a multitude of issues. Before I can describe our unique approach to tackle this problem, we will need some background. So if I tell you that there are these 3 columns of words, and we are trying to find out which of these columns are close to car, then if we look at the red column, we see that vehicles, okay, I mean, this column might be close to car because vehicles is a generalization of car. Truck and ambulance are specific types of car. Bike, not so much car, but still we can use it to go from point A to point B. What about the blue column? We would still say that, yeah, these words are also related to car because these words can co-occur with car in a sentence. How about the third column? We will say, no, not so much related to car. So the idea is words are close to each other if they share contexts or appear in similar contexts. It can happen in the case of in 2 different ways. If the word is a synonym or a near synonym, then suppose the sentence is, I went for a car ride, you can just replace the car with the word bike and you will still have a sentence that makes some sense. So this is how near synonyms and synonyms share context. And in the other type of words that are related to car, they can co-occur in a sentence with car, and that is how they will share context. A breakthrough result was obtained in 2013 when a group of researchers found then you can actually assign words in a language as a point in a high dimensional space such that the distances between the words in this high dimensional space somehow captures this notion of closeness. And the technical term for this is word embeddings. Now, I cannot show 100-dimensional a description of these word embeddings on a PowerPoint slide. So I'll show you a 2-dimensional approximation of how this looks like. So on the left side, we have English word embeddings. On the right side, we have Spanish word embeddings. By the way, quick question. Are you able to see my cursor? Okay, that's very useful. So you can see that in the left side, we have some English numbers and their representation, and animals and their representation. And we have the same numbers and animals represented in the Spanish word embedding. If you carefully notice, you will see that there is some kind of isomorphism in the two structures. So if we can learn a linkage function between the English embedding to Spanish embedding, we will be able to perform word translation. And the way mathematically this works is, say, this is the coordinates of horse and this is the coordinate of caballo. If we are able to learn a transformation such that if we multiply it with this transformation and we get the coordinates of caballo, we will be able to perform word translation using machine learning. And with the same transformation, if we can also translate cat, which maps to gato, then we will be able to broadly generalize this translation method, and we will be able to translate several words. So the way then this works is we have word embeddings, two of them of two different languages. If our source language is English and we want to translate it to Spanish, then language source is English, language target is Spanish. We need few example pairs so that we can know some of the subset of these points and where do they map to. And this small set of example word pairs, say hello, hola, fish, pescado, we have this small set of example word pairs. And then the machine learning method learns a transformation such that if we get the coordinates of the source word and we multiply it with this transformation, we get a target word in Spanish. So formally, this is basically let L source and L target be two languages with vocabularies V source and V target. And the translation scheme from language of source to language of target computes a transformation W and takes a word W source belonging to the source vocabulary as input and outputs a single word translation W target such that the target word belongs to the target vocabulary. And when we multiply the source word's coordinates with the transformation, the resulting value that we get is closest to the target word. And we define distance as cosine distance. Now I think we are ready to describe our proposed solution. Here again, I'll take an example of two news networks, say CNN and Fox. And we assume that the two sub-communities are speaking in two different languages, language of CNN and language of Fox. Now, they are actually speaking in English. So what does it even mean that they're speaking in two different languages? And what does it even mean when we say that we translate each word belonging to language of CNN into language of Fox? If we think in terms of dialects, then if we try to translate, say, British English into US English, then the word flat in British English will translate to apartment in US English. But in this case, we are actually trying to translate two communities who are literally speaking in US English. In an ideal world, apple in language of CNN should translate into apple in language of Fox, or tree in language of CNN should translate into tree in language of Fox. Here, however, we focus on word pairs that do not translate into themselves. So we focus on the mistranslations, and we call these mistranslated pairs misaligned pairs. When misaligned pairs appear in similar context, they often signal political and ideological disagreements. So in this table, the left column are comments on news videos from CNN, and the right columns are comments from news videos on Fox. And you can see that Republicans and Democrats appeared in mirroring context. Republicans are the greatest threat to America. Democrats are the greatest threat to America. Republicans are traitors. Democrats are traitors. I'll never vote Republican again. I'll never vote Democrat again. No wonder why, if we used a machine learning based approach to perform word translation, Republicans in CNN English will translate to Democrats in Fox English and vice versa. So our process is quite simple. We have two sets of word embeddings, say trained on Fox News discussions and CNN News discussions. And remember that previously we had some set of training examples like pescado, fish, hola, hello, so that we could translate from Spanish to English. In this case, we are literally translating English to English. So we address this problem of training example by saying that stop words or the very high frequency English words like and, about, or, we say that no matter how politically polarized these communities are, and in CNN English is same as and in Fox English, or about in CNN English is same in Fox English, about. So with this small sets of examples and these two embeddings, we align them using a well-known algorithm. And then the intuition is, if two communities are really far, far apart, more and more mistranslations will happen. And if two communities speak very similar languages, fewer mistranslations will happen. So just by counting the number of mistranslations, we can create a quantifiable framework to put numbers to how similar two communities are. So basically, we are computing the percentage of words that translates to itself, and higher this value, the two communities have better agreement. And mathematically, this is just similarity between two languages, language source, language target. And the indicator function returns 1 if the word translates to itself. So we are just counting how many words translate to itself. Before I go to the quantitative result, the qualitative results are quite interesting too. So these are some misaligned pairs from CNN to Fox. Remember that in an ideal world, Democrats in CNN English should map to Democrats in Fox English. But we see that interesting misaligned pairs like Democrats, Republicans, a Dem Republican. This one is particularly interesting, Kushner-Burisma. Kushner is the son-in-law of former president, and Burisma is the oil company with which Hunter Biden had some controversy. And Hunter Biden is the son of the current president. So you can see there is a hint of alleged nepotism in this mistranslation. The inserts are quite interesting too. We have a mistranslation pair of Trump tards and snowflakes. So Trump tards are used to as a derogatory term to the Trump supporters, and snowflakes are often used to insult the liberals. We have a mistranslation pair over there. In the ideological section, we have the usual suspects like liberals, conservatives, or liberalism, conservatism. But we were very shocked and deeply disturbed to see this mistranslation pair, KKK BLM. And we thought that, is this even happening for real? We wanted to look at the data set, and we found that, yeah, actually, KKK and BLM indeed appear in mirroring context across two different communities. So again, the left side of the communities are discussions from CNN news videos, and the right side is discussions from Fox News videos. And we can see that KKK and BLM indeed appeared in mirroring context, which is a very shocking and disturbing finding. This result received a substantial media coverage, and rightly so. And also the broad idea of the liberals and conservatives speaking languages so different that machine translation methods are able to pick up these differences also generated quite a bit of interest. Now I think we can look at the quantifiable side of our algorithm. So this is the matrix that shows the pairwise similarity score between these languages. If we focus on the top row, we see that language of CNN is 94.2% similar to MSNBC and 90.2% similar to Fox. So CNN is more similar to MSNBC than Fox. If we focus on the second row, we find that Fox is more similar to CNN than MSNBC. And the bottom row tells us that MSNBC is closer to CNN than Fox. So if we combine all these three relationships and we put MSNBC at the left, a very logical arrangement will be MSNBC, CNN, and then Fox at the right, which also aligns with our common knowledge. Now, our finding can also scale to multiple networks. If we consider One American News in the mix, we find that here is MSNBC, CNN, Fox, and then One American News at the far right. But news networks are not the only source of information these days. I can admit that I often watch political comedians to get my information on the current events. And over the last few years, these comedians mostly covered US politics. So we constructed another data set of more than 4 million comments on videos from these prominent political comedians. And we wanted to know linguistically which news network they are most similar to. And we were not very surprised to find that the language of the comedy viewers is somewhere between CNN and MSNBC and far from Fox. On a much more serious note, we have written a follow-on paper investigating the role of fringe news networks in the Capitol riot. And in this work, we considered 3 fringe news networks: Blaze TV, One America News, and Newsmax. And we also considered a data set of the former president's official YouTube networks video comments. And we wanted to know linguistically which news networks Trump followers are most similar to. And we found that a language of Trump is most similar to Newsmax, followed by One America News, then Blaze TV, then Fox, then CNN, and then MSNBC. Remember that One America News and Newsmax were the 2 news networks that were spreading the maximum news items of unsubstantiated claims of voter fraud. And the fact that our method can shed light into this kind of deeper insights, where we can see that the followers of a political figure, which news networks they are linguistically similar to, shows that our method holds promise in finding this kind of deeper insights. Now, we had a data set of more than 85 million comments. And it's not feasible to read all of them to have an idea of how these large-scale communities differ on which specific ideas or concepts. But if I tell you that solar in language of CNN translates to fossil in language of Fox, we immediately know that there is a debate surrounding the energy issues. Or if I tell you mask in language of Fox translates to muzzle in language of One American News, we immediately know that even in the conservative spectrum, there are differences, and there is a subcommunity that thinks wearing masks somehow interferes with our freedom of speech or expression. So that is why this method is extremely efficient, because we can just look at salient pair of these kind of mistranslations, and we can interpret where these differences are coming from. Beyond single word, we have tried short phrases, and again, this is a very disturbing and shocking result. We found that Black Lives Matter in language of CNN is closer to All Lives Matter in language of Fox than Black Lives Matter. So we found that using our unique approach of treating subcommunities speaking different languages, our methods can shed light into the divergent views on racial inequalities and racial injustice. Finally, this method is not just restricted to US political crisis. In a more recent follow-on paper, we have worked on Twitter data on the 2019 South American protests, and we found that if we consider the 2 subcommunities, one in favor of the protest and one against the protest, we will have mistranslation pairs like comunismo, fascismo, or socialista, capitalista. So this gives us an idea that our method holds promise in transcending language, because it's a different language. It's actually Spanish to Spanish translation now. And then it transcends a different political crisis, because this is a different political crisis. And also, it transcends different social media platforms, because this is Twitter data in which we ran this experiment. To sum up, the socio-linguistic impact of this work is different words may be used in near identical contexts in different communities, and such words may inform us about the fundamental differences between these communities. and machine translation methods. To our knowledge, we are pretty sure that this is the first work where we tried subcommunities speaking in different languages and using machine translation to shed a light into polarization. This is the first work that has done that. It provides a powerful, interpretable, and quantifiable framework. Now, I'll move on to part 2 of this talk, where we talk about a novel framework to mitigate hate speech. This is a very oversimplified Venn diagram of social media discussions, where there is one set that is hate speech and another subset that is not hate speech. And then there is a gray, or in this case, I think the purple zone, where it's very hard to detect if the comments are hate speech or not hate speech. Large majority of the papers in tackling online hate mostly focuses on this part of the content, where the goal is to detect hate speech to the best of our abilities, and then try to track users who are posting hate speech content, or how can we delete content that is hate speech. So that is the main focus. However, we often overlook the not hate speech subset, where we can have positive content with societal impact. And we say that it may not be enough to just block the hate speech alone. In parallel, if we can highlight and detect this content with potential societal impact, that might be an effective mitigating strategy. And we present two compelling real-world scenarios. One is online hate between nuclear adversaries at the brink of the war, and online hate targeted at disenfranchised refugee communities, and show that in these two cases, blocking hate speech may not alone be enough. In parallel, if we can also detect and surface the positive content, that might have some benefit. So this brings to us two new tasks we have defined. One is of hope speech detection, that is to detect hostility diffusing, peace-seeking content in the context of 2019 India-Pakistan conflict triggered by the Pulwama terror attack. So when two nuclear adversaries are at the brink of a war and civilians are engaged in heated political debates calling for each other's heads, in that context, just detecting hate speech and blocking it may not be enough. In parallel, if we can detect and surface comments that are talking about hostility diffusion or talking about peace-seeking intent, that might be important. In a similar vein, when a disenfranchised minority is suddenly thrust into global discussion, people are rapidly forming opinions about them, and maybe the majority opinion is negative. They may not be even present in that discussion to defend themselves. And their absence may stem from lack of internet access, or the discussions are happening in a global language that they're not that proficient at, or simply they're just too busy to run for their lives. So when they are not there to defend themselves, and a handful of people are championing them, then it will be very important to surface content supporting those disenfranchised minority, and we define a new task of help speech detection in the context of the Rohingya refugee crisis. We will still need to have a little bit of background of these two particular crises to understand what this entails, like how many people can be affected in these two crises. So the India-Pakistan conflict in 2019 started with a suicide bomber attack from a militant organization, Jaish-e-Mohammed, from Pakistan, and that killed several soldiers in India in Kashmir. Soon after that, the diplomatic escalations start happening, and it reaches a crescendo when in 26th February, the India government announces that they conducted a massive airstrike inside Pakistan. The two countries come precariously close to declaring a full-fledged war when an Indian Air Force pilot gets captured by Pakistan. Up until on 1st March, the Pakistan Prime Minister said that they will release the Indian Air Force pilot as to reduce the tension. And for the time being, the de-escalation happened, but the history of India and Pakistan and their conflict has it's a long history of 70 years, and it's surrounded around Kashmir, a disputed region since the inception of the two countries. There have been four full-blown wars and several skirmishes. Both countries are nuclear powers, and a recent study reported that should there be a full-fledged war, there could be as many as 100 million deaths. So while this political tension was a long-standing tension, our work was the first ever work that analyzed the web manifestation of this conflict. Similarly, the Rohingya refugee crisis also affected millions. So it's an ethnic minority. Rohingyas are an ethnic minority in Myanmar, stateless since 1982. And nearly 742K of them have been displaced in the last 10 years. And major ethics organizations reported brutal state-sponsored violence against them. So now you can see that both crises affect people in order of millions. And we have defined these two new tasks, one to hope speech detection to detect hostility diffusing peace-seeking content, and another help speech detection to detect content supporting disenfranchised minorities. So hope speech classifier is a nuanced classifier detecting hostility diffusing content. The definition we have written in the paper is quite involved. I'm just giving few examples here. It could be about expressing peace-seeking intent. It could be about expressing humanitarian cost of a war. It could be expressing appreciation for neighbor, or so on and so forth. And our dataset consists of 2 million comments on around 3,000 videos, YouTube videos again, relevant to this crisis. Similar to hope speech classifier, help speech classifier is also a nuanced classifier that can automatically detect comments supporting the Rohingyas. And it could be about seeking organizational help, condemning the alleged oppressor, expressing empathy, or vocalizing the right for the Rohingyas, and several other subcategories. And as a dataset, again, we have 263 comments on more than 5,000 YouTube videos relevant to the Rohingya refugee crisis. Before we can form opinions on how sophisticated machine learning or natural language processing models we can use here, we first need to understand the linguistic landscape. Multilingualism creates a tremendous challenge in tackling datasets from this geographical region. India alone has 22 languages recognized by its constitution. Many of these languages are not supported by commercial solutions like Google or Facebook. And to make things worse, much of the content is written using Roman script instead of the traditional script of these languages. So Romanization makes it even harder to detect language. Even if we manage to detect English, working with the English dataset is not easy either. Many of the speakers from this region are non-native speakers of English. And that leads to tremendous, often varying spelling and grammar disfluencies. For example, this is a comment from our data set, Pak Prem God bless you, my int pilot. So God bless you is basically God bless you. So you can see that pilot, thanks, country, all these words are incorrectly spelled, making analysis extremely challenging. Any idea what is this word? I won't be able to see the chat now, so I'm just giving away the answer. This is virus. And what is this phrase? This is actually sanitizer. So you can see that this data set is extremely challenging. And on top of that, code switching makes it even more challenging. Code switching is a phenomena where people seamlessly switch between multiple languages, and it happens very often in multilingual regions. This is an example where the first part is written in English with lots of spelling and grammar disfluencies. Second part is written in Hindi, And the Hindi word Shanti, which means peace, is also incorrectly spelled. So you can see that this is highly challenging landscape. So that's why NLP research on South Asian social media typically focuses on English content. And as a result, large volume of data in highly prevalent first language often gets ignored. One such example is Hindi. Hindi has nearly 500 million speakers both in India and Pakistan. However, very sparse resource, linguistic resource as compared to English. To make things worse, 90% of the user-generated web content is written in Romanized Hindi, and Romanized Hindi has even sparser resource. So along with these linguistic challenges, we also have additional machine learning challenges. That is this small green blob that we are trying to detect of positive content. This content is quite rare. So if we randomly just sample from our India-Pakistan dataset, we will get 2.5% hope speech. And if we randomly just take comments from our help speech dataset, only 10.77% are help speech. So learning with rare positives is another challenge that we have to deal with. So combining all these things, we have three challenges. First, how can we extract a reasonably clean English corpus? Second, how can we construct balanced and diverse data set to train a supervised solution? And finally, this is the most ambitious goal. If we have an English hope speech classifier, can we use that to detect Hindi hope speech? So I'll talk about the first challenge now. So here, previously we talked about how we can map words into a high dimensional space. We have come up with a new way to map documents into a high dimensional space such that documents of same language are placed close to each other. And again, I am just showing a two-dimensional representation of this. In the right side, we have 21 European languages, and you can see all of these languages clustered very separately. And up till this point of clustering these documents is automated. It does not need any labeled examples. Any annotation is required. Once we have this cluster, for each of these cluster, we just need to pick 10 randomly sampled documents, and we have to look at the language of these documents, and we can assign a language label to each of these clusters. The reason this method is extremely useful is because for these 21 clusters, we will just need 210 annotated examples. So annotation is a large, is a very costly thing in machine learning, where if you have to label examples, it takes a lot of manual effort and resource. So with just 210 labeled examples, we will be able to have these 21 language clusters. And then whenever we have a new document, we just have to compute its point in the high dimensional document embedding space and find which cluster it is closest to. And that's how we can just perform language identification in a very annotation efficient way. To look at this 2D representation, this is our India-Pakistan corpus. And we can see that there are three different clusters. Hindi in Devanagari is a smaller cluster, Romanized Hindi, and then English. And we just had to annotate 30 comments to process these 2 million comments and detect language of each of these comments. So that's how efficient this new method that we have proposed is. And we compare pretty favorably against solutions coming from big companies. So these are FastText is Facebook's language identifier, and Google LangID is Google's language identifier. You can see that in this challenging data set, we do better than solutions coming from commercial giants. But that is not the only reason our technique is important. First, our technique is important because it's highly annotation efficient. We do not need too many labeled examples to support languages. Second, we are able to adopt this technique to analyze a lot of South Asian events, such as the Indian general election or the Chennai water crisis. But finally, the most important part of our advantage of L polyglot, our language identifier, is it can support language that are yet unsupported by commercial solutions like Google. If you can try this example actually even now, if you ask Google language detection system to say what is this language of this particular text, it will say Bengali. It is not. It is Assamese. And our method is correctly able to detect that it's Assamese. And the reason this result is important, because Assam is in the forefront of a huge controversy that is happening in India related to a citizenship amendment bill. So when you empower a language that doesn't have resource, you not only empower the language, you empower the problems, the movements, the challenges faced by that community, and you can make those things much more visible and feasible to analyze. So that's the main social linguistic impact of our linguistic solution. We have addressed a multitude of machine learning challenges in constructing our data set, but I would not spend too much time in describing this because I want to talk about the next result that I think is much more interesting. And I also want to show some of the results what our classifiers found. So once we constructed our data set and developed a supervised solution, we can see that our automated method is quite precise. So compared to 2.45%, our automated method can detect hope speech at a precision of 85%, help speech at a precision of 88%. This means that if you are a web moderator and you have millions of comments to choose from, if you rely on our classifier's prediction, 9 out of 10 will be hope speech or help speech. And then if you want to surface those content, it will be much easier for you. This again received a lot of attention from digital trends and VentureBeats. And here is one example that we found in the wild, our automated method, which is originally by Herodotus. In peace, sons bury their fathers, and in war, fathers bury their sons. This is recreated by a YouTube user some 2,500 years after Herodotus came up with this quote. And it just doesn't say anything about our classifier or our method. It actually tells a lot about our mankind, that it's been 2,500 years and we are yet to realize the futility of war. This is an example help speech found in the wild. And I'll pause for a few seconds so that you can read this comment. So you can see that the word citizenship, ethnic cleansing, even the word help is incorrectly spelled. And most likely this is a comment written by a Rohingya refugee user. And the fact that our classifier could automatically detect this in the wild indicates that our classifier has a lot of promise in lending voice to the voiceless. It's also not all doom and gloom. These are some of the help speech examples that we found in the wild. All the countries should take a stand for these people and force Myanmar government to accept them. No country is too small to take on refugees and camp them for a period of time. Or can someone tell me where I can help charity to them? Similarly, when we did an analysis of how the peace-seeking and war-seeking intent evolved over time, we found that when the threat of war became real in our India-Pakistan dataset, the peace-seeking comments heavily outnumbered the war-seeking comments, indicating that when the threats of war became imminent, common people tend to gravitate towards peace, at least in this particular case. So that says that it's really not all doom and gloom, and people do post positive content in the internet. And if we can detect this content, then we can bring in a lot of societal benefits. Now we go to the final challenge. Given an effective Hindi hope speech classifier, English hope speech classifier, can we detect Hindi hope speech? So recall that we found that Romanized Hindi was almost as much, had as much presence as English in our India-Pakistan dataset. So when we talk about finding the positive content, if we just focus on English, then we are actually not looking at a large subset of the positive content that we could detect. This is an interesting observation. For those who don't understand Hindi, "Main aman chahta hu, khuda ke vaste jang nahi" will probably make no sense. But "I love India, I am Pakistani, peace, peace, peace," you'll say, yeah, this sounds like a hope speech. The fun part is, this is part of the same comment. And it's an example of code switching, which I was telling you before, where people seamlessly transition between languages within the same document boundary. Code switching has been typically looked as an obstacle in downstream analysis and has been researched by linguists for 50 years. However, here we find an advantage in this kind of mixed language because a short document is likely to express a consistent sentiment. Even if I don't understand what "main aman chahta hu, khuda ke vaste jang nahi" means, I can still have an educated guess that given this is part of an English comment that is hope speech, most likely this is also telling something about peace. And if we can linguistically separate this Hindi reliably, then we can use this notion of sentiment parallelism and perform, we can harness code switching to perform cross-lingual sampling for social good. This will become much easier if I give you an example. So if we go back to our earlier example, we have to extract the Hindi subpart of this comment, right? And it turns out that L polyglot, the solution that works well at document level, also works well at word level. It extracts "main aman chahta hu, khuda ke jang nahi" as Hindi. The vaste, it makes a mistake. It thinks it's West. But nonetheless, once we extracted the Hindi subpart, we were able to sample nearest neighbor in the document embedding space. That is an out and out Hindi comment, and it translates to, "I am a Rajput. I never want fight between the two countries. We were one country before the partition. Only a handful of extremists want bloodshed." So visually, this means that this blue region is the English documents, red is Hindi, and within the black region, we have these magenta triangles that are code switched hope speech. Once we extract the Hindi and find nearest neighbors of these extracted Hindi documents, we see that it is spread all over the Hindi region. So we are able to transcend the linguistic barrier using this code switching phenomena as a bridge. And if we just randomly sample, we will get 1.8% hope speech, and our method just improves it by 31% to 31%. So all this just comes for free, just using this sentiment parallelism and code switching as our idea. In a more recent follow-on paper, we have shown that it's possible to use unsupervised word translation to improve this number from 31 to even 46%. And this is an end-to-end unsupervised solution where we are just relying on English hope speech classifier to detect Hindi hope speech. So the socio-linguistic impact of this work is we talked about framework novelty, where we focus on the positives as opposed to the negative content. And we argue that there is a lot of positive things that is happening over the internet. And if we try to highlight them, this world can improve. We proposed a new language identifier that addresses the challenge of detecting languages in South Asian region. And when we empower minority languages, we not only empower the minority languages, we also pave the way to analyze problems faced by people who speak them. And finally, code switching, that has been researched by linguistics for the last 50 years. But to the best of our knowledge, this is the first work, ours is the first work that indicates its potential for cross-lingual sampling for social good. I have been extremely fortunate to work and collaborate with a series of distinguished names at CMU. Jaime was my PhD advisor and postdoc mentor. I got a chance to work with Kathleen through her student Ramon, who took our course on tracking political sentiments using machine learning, which I team taught with Professor Mark Camlett and Tom. Tom is my current mentor. And my if I'm not mistaken, then I'm the only person in this planet who has a paper with everyone in the top row of this slide. And I'm very lucky to work with Shifani Palakodeti, my friend and collaborator, Rupak, my student, and Raman and Helen took our course on tracking political sentiments using machine learning. This talk is dedicated to Professor Jaime Carbonell. I was his PhD student and postdoc mentor. I was his PhD student, and he was my postdoc mentor. And I had a 9-year of history of collaboration with him. The work of Hope Speech and Help Speech, he coined both names, and this was very close to, this line of work was very close to his heart, and I dedicate this talk to his wonderful memory. And I'm happy to take any questions. Thank you.
Ashique, thank you very much for the great talk, and we'd like to open it up now to questions. Feel free to just call out your question, or or to raise your hand, either way.
I'm not sure how to raise my hand, so I'm just going to call out a question. This is Danny Oppenheimer. I'll put on my screen so you can see me. I thought this was fascinating. Great methods that you've developed. Really interesting stuff and really useful. And I'm curious about the inferences that one can draw from these sorts of methods. How representative are the YouTube comments for YouTube users? You can totally imagine that there's a small minority who are commenting, and thus the language that you're apparently revealing is actually not representative of the community as a whole. There are a lot of bots that go through. I've talked to Dr. Carly about this. A lot of bots could be propagating use of language in various ways that may not be naturalistically representative of the community as a whole. Similarly with trolls. And so I'm curious, your method is going to be really useful for all sorts of things. And so from the methodological perspective, I have no concerns, but from the perspective of being able to draw inferences, how much can we learn about a community from the samples that you're drawing this information from?
It's a very interesting and good question, and I think that the line of literature that we have to tackle and detect the trolls and bots, if we can apply those things to our data set and clean our data set before we can run all this analysis, then the analysis will be much more meaningful. We have also tried in our own way to use some kind of user filter. For example, if there is a user who mostly comment on Fox, but only comment once or twice on CNN or MSNBC, we have used a filter to assign a news network label to each of these users. And then we have filtered the data set so that these are only Fox majority viewing user and CNN majority viewing user. And we have tried to translate and analyze that. The question of representation is also a good question, because a vast majority of internet users are often silent and they do not comment. So that's a challenge. If you're working with social media text data, that's a challenge we will always face. So we will have to back up our findings with other signals, and that is also something that we have done in our paper, where we used video likes and dislikes, and we have computed ratios of dislike over like plus dislike, and we have shown that healthy news networks, where a lot of diverse opinions or a lot of diverse audience they frequent, in those cases, their dislike over like plus dislike average value over a long period of time is closer to 0.5. And for One America News or Newsmax, the value is closer to like 0.01. So like we actually use multiple different signals to complement text. But I think Kathleen's research group, they do wonderful work on bot and troll detection, and those work, if we apply to networks and then clean up the network and then analyze the text, it will be much more representative and much more interpretable.
Thank you.
Hey, yeah, this is really cool stuff. I guess along those lines too, have you taken a look at different time periods in your analysis of like how similar Fox is to OAN and or how similar they are to Trump and those kind of things? Because I can imagine that over time, different networks kind of flow either way or towards each other.
Yeah. So this actually one thing that our method requires is a large amount of data, like because we have to train these word embeddings and then we can compute the differences, right? So making temporal conclusions is still like a challenge that we are trying to find a good way to address, because then we will have to have, say 2016, we didn't have that much comment. 2020, we have much more the comment. So I think if we get to a point where these data hungry methods have enough data, we will be able to analyze temporally. And also it will be very interesting to know when did solar became fossil, right? In like CNN English to Fox English, when did the transition happen and how the two words were coming closer and closer. So yeah, I think the temporal aspect is a very interesting direction.
Thanks. And yeah, I guess an idea that goes along with the previous comment is if you had a data set of additional comments that weren't on the news networks, but were on a specific topic. So again, you might have a data problem. We're trying to find enough data for these topics, but if you can find a broader range of YouTube channels beyond kind of the what we kind of know starting out are relatively partisan networks, that might get you an idea of what the more general conversation is. I mean, they're all going to have problems with bots and or just intentional users trying to change the conversation. But that might be a way to get at this idea of, are you just measuring the comments of the language of people that are making comments on these news sites, or is it broader to the general population that's discussing these things across different kind of YouTube channels?
We have answered that question partially with our experiments on the comedians, right?
Right.
I mean, political comedy, I mean, they're still comedians. I mean, they are not news anchors. But still, I mean, we found that their discussion is somewhere between MSNBC and CNN linguistically.
Yes, thank you. Fantastic contribution. Thank you, Ashique. It'd be great to follow up with you. In fact, we're doing, similar work, but also developing models that ingest data representing real phenomena, right? So data representing real phenomena from the social, including economic, demographic world, which includes this data, i.e. perceptions of humans, feelings of humans, and then the built world, and of course the natural world. So real phenomena, perceptions of those phenomena. What we also find is this difficulty in obtaining representative samples unless you use, organizations like ReWe have these online these online survey methods that just randomly select IP addresses, and people get online and then they can access them. So to some extent it gives you representativeness. But to go to to marry a question that preceded me actually to the question I was originally going to ask, which is first, you have a risk that we also find if you're using the comments from YouTube or Twitter. Of course, we don't need to get into Facebook given the inaccessibility of that data and their terms and conditions. But if you're to use this method and you have this difficulty of obtaining representative samples, then that also to some extent goes to this question of how do you designate what constitutes hate speech, right? Before you come to this issue of hate speech, right? If you look at the definitions, and multilateral processes is what, in particular, then you need to make assumptions about the intent of the person saying the language, right?
Correct.
Like there's a difference between discriminatory speech and hate speech. So like for us, I guess we're probably a bit more reticent to use the term hate speech, firstly, because we don't have data that indicates the intent of the person. We just have the language text that they use. And you can say this is discriminatory, and there are emotive or demeaning negative terms that, you know, the word embedding and all that can marry them together, and that's great. So my question for you is, have you attempted to employ this in contexts where you've used methods to attempt to explore how you can sort of narrow these data gaps? I don't know if that was a very clear question, but I guess begin to explore potential methods to overcome these barriers in, you know, data scarce, or I guess you might call it data imperfect environments.
So what we have found that when the like our machine translation based methods, when they don't have enough data, they still the interpretability suffers a lot, because then you will have mistranslation pairs that do not make much of a sense. But the quantifiable part still remains intact. So with sparser word embeddings, it works. In case of hate speech, what you are saying that it's very hard to detect the intent, but we have a recent paper where we found that it's very hard to detect at the content level as well. So we just used state-of-the-art hate speech classifiers and fed those hate speech classifiers some chess discussions, where people are saying that black queen is threatened by white knight. And the hate speech classifiers are it has just seen black white threat attack all these things in a very overfitted situation that it immediately falsely flags chess discussions as hate speech. So I feel that to answer your question, I mean, addressing this kind of data gap is a very big challenge. And one way I'm trying to address is to figure out where things break, like some adversarial situations, and then try to include examples from those domains so that these kind of data gaps can be addressed. Does this answer your question?
It does. It does. Thank you so much. May I follow with a very quick question, moderator? Yeah. Have you attempted to test the relationship between these designations of the existence of, you know, however you define hate speech, or the or hope speech, for example, and change in another dependent variable? So have, say, for example, levels of violence in a situation, or as the dependent variable where you use commodity prices, change in climate, change in other event data, or anything like that?
No, we haven't done that, but I think that is something. I mean, like there are just like so many more things to do in this space, and we haven't explored this direction. We have also, although tried to explore that how the fraction of hope speech evolves over like temporally, like as the political tension heightens, and like when the two countries come precariously to war. So we have explored that direction, and we have found that when like threats of war become real, actually a lot of people express peaceful content. And coming back to one earlier question, where the question was like how representative of is YouTube when these discussions happen, we found an interesting phenomena that when the threats of war became real, the people who commented were new people. They typically do not comment on YouTube videos saying that war is a bad idea. But when they just realize that stakes are high and we need to participate in this discussion, so the participation pattern also changes. So that's something that was very interesting that we observed.
Thank you, Ashique. Dr. Carly did have to go to class, so I'm just going to take over
So I see
moderation here.
Jan raised hand.
Yeah.
So can you unmute yourself and just ask the question?
Hi, Dr. Ashique. Thank you for the talk. It was really great.
Thank you.
I really enjoyed several aspects of it. My major question was, have you tried using these techniques on Twitter datasets instead of YouTube ones? And have you faced any problems with that, or like any challenges?
So machine translation based work, we already had a follow-on paper with Professor Carly, where we looked at the 2019 South American protest. And there we were considering Twitter and Spanish data sets. So that work works. And I don't see why we will have any problem with Twitter, because YouTube and Twitter, the noisy nature of the text will just remain pretty much the same. So it should work. But Twitter comments have that restriction that it cannot be arbitrarily long. That might add some nuances, but it should work.
Okay, so you check comments against like major posts. Is that how it worked on Twitter?
Say that again. No, I mean comments on YouTube videos and tweets. They will be the text will be roughly of similar nature. So our work should, like all our methods should work on Twitter data.
Yeah, so one major question I had about Twitter was how was the categorization of the tweets done? Like in YouTube, it's very easy to categorize Fox News channels.
So you're saying that if it's coming from Fox, then we immediately know that is a comment. Yeah, so in categorizing, I think in our paper on South American politics, we used hashtags and political retweeting behavior. Like if you are following some particular politician and who are in favor of the protest, then likely you are also in favor of the protest. And if you are retweeting their tweets, then likely you are also favoring the protest. And that's where you were mining the first figuring out the stance. And then once you have figured out the stance, then you separate the users. And once you separate the user, then you look at their tweets and perform this kind of analysis. So that's how we performed it with tweet.
If not, I just want to thank you, Ashique. This talk was really,
Thanks for giving me.
yeah, it was great. Here, our next ideas seminar date is April 21st, and that will be with Joshua Tucker, Professor of Politics at NYU. So, thank you again, Ashique, and thank you everyone for coming.